Hello everyone. Today I wanted to share just a brief presentation explaining my group's project. And so before we get started, the name of our project is Neural Draw. And of course this was for the UMGC CMSC 495 class. My name is Mason Conaway, and then these are the other four members of my group. There were five of us total. And yeah, let's just go ahead and get started. So at its core, our project is a piece of software, and this is developed both as an educational tool as well as an interactive artistic experience. But before I go into too much detail, let me just show you the project and then I'll explain kind of what it does as we go along. All right, so let's break this down a little bit. So here we have a white canvas where the user is able to draw a picture. So let's just go ahead, make a little face. And then we also have options for changing the size of the brush. So I can make it really big, really tiny. And I could also undo my last stroke using this button down here. And then if I want to clear, I can also clear the entire canvas all at once. And then there's also one more option, which says Analyze Drawing. So before we do that, let's just go ahead and draw a picture. So let's make the same smiley face as before, or you know what? Yeah, just make a little face. I think it's pretty clearly a face, right? Press Analyze Drawing. Now, basically, when we click this button, there's a drawing that we made, which is uploaded to a server, which we made using Python's Flask library. Then that server sent it off to our AI model that we trained called a convolutional neural network, which is essentially an image recognition AI that we trained using hundreds of thousands of images taken from an open source library hosted by Google. So our AI model, it breaks down this doodle into individual lines, edges, and white space, and then it compares it to the training data, and it tries to make a guess as to the image that we drew. Then it sends a prediction back to the drawing application through the server. It grabs that data, and then it presents it on the screen. And so, yeah, that's basically what just happened here. So we returned a confidence for our top result, and that's displayed on this top border. Did you draw a smiley face? Now it says it was only 8% certain, which is pretty bad. It's probably because my drawing is bad, so I'll give it another try in a minute. And then its uncertainty was 91.69%. We also showcase its top 5 predictions total, so you can see kind of what else it thought you might have drawn. And sometimes these are a little bit not the greatest, but it gives you a perspective into what the AI is doing, how the AI is breaking this image down. You also might have noticed that there's this huge list of objects we're able to draw, and this is the training data, on the training data classes. So there are 63 different objects here that the AI is trained to recognize. And so let's go ahead and clear this and let's try picking something else from here. Let's try a butterfly. That seems pretty easy, right? So now again, I'm not at all an artist. But if you ask me, it's got to be a butterfly, right? Let's press analyze. Yeah, butterfly. 99.99%. Its other predictions, it thought it might have been a bee, thought it could have been grapes, a dog, or a flower. Flower, I can see a flower. Flower's pretty good. Let's actually draw a flower real quick. Give it one last test. I think that's pretty awesome. Yeah, flower. 99.99% confident. Um, and you also might have noticed that there's this little tiny box at the bottom. This is the actual image that gets sent to the AI model. The AI model is trained on these 28 by 28 pixel images for a couple reasons. One of the big ones is because it saves on like computational power if the images are really small rather than super large. Another one is that the AI model has to be trained on the same size image that you're giving it. And since the training data was 28 by 28 pixel images, that's what the open source Google library has, 28 by 28 pixel images. We had to give it the same size image to give the most accurate results. Anyway, let's go ahead and clear that. Yeah, so that was basically the whole program. And yeah, I mean, while we were making this project, we learned so much about systems designs, servers, neural networks, and there's so much more too. One of the challenges that I wanted to quickly highlight was actually in reference to the image recognition feature. So when we first started gathering data to train the model, I found this website with like a library of thousands of pictures of real life objects specifically for object recognition, and it had pictures like as cats and dogs and different street objects in a city. And so I pulled that as the training data and I trained the AI on those pictures. But then when I uploaded that model to the application and I tried to draw a picture, every single time my confidence was 0%. Um, and I had no idea why this was happening. I really spent a lot of time trying to figure out what was going on. Then it finally clicked. The neural network was trained on real life pictures. And so it was expecting me to send it another real life picture to guess the object. And it wasn't trained to recognize doodles that were drawn by humans who have these like artistic imaginations and liberties. And so I had to find a brand new set of data to retrain the model. And that was like a full 24-hour period of time where I was retraining the model, finding new data, retraining the model, until we finally settled on something that was really a really good balance, and it was able to predict it correctly almost every single time. Um, yeah, for things that we could have done better, I mean, I think that the application it works almost flawlessly. I really love every part of it. Um, you know, things we could have done better. I guess we could have spent more time making the application look pretty, giving it nice colors. Um, it would have been nice as well to turn this into a website, or at least make a website homepage featuring our application, something like that. Um, One other thing is that we wanted this application to run on any device, um, whether they had an internet connection or not. So we actually have the server hosted by the application. So the application starts the server itself, and then the person who's running the application has the model downloaded on their own computer. Um, Ideally, if we were going to publish this somewhere as an actual product, we would want to have the server hosted somewhere else and have the user connect to the server. And then we would need to introduce things like rate limiting the API so that they can't just spam the analyze drawing button over and over and over again, and like overflow, like flood the server. Um, and then we would also only give the user access to the actual application, the server, and the model, and all our other things like such as like the code for training the model, analyzing the data, grabbing the data. All these things would be taken away from the user. All they would have access to would be the actual drawing application. And then I also wanted to showcase this last minute. We ran a test over all of our training data, and these are the average success rates and the average confidence. And you can see a lot of these are really high, between like 75 and 90%. Even a couple of them are really high. You have a couple that are really low. For example, a dog, and the moon. And I think a lot of the reason why we have these low confidence um, results is because some of these objects can be easily confused with other objects. For example, we have a moon here, but we also have the sun is also a category, and so is just a regular circle. And so because a moon could be drawn as a crescent or it could be drawn as a full moon, there's so many different ways you can draw a moon. The AI probably couldn't very easily distinguish the difference between what is a circle, what is a sun, what is a moon. Um, and I think that was probably a big reason why we had a low confidence for things like the moon. For bird, we also have a category for a duck, which they're the same thing basically. Well, a duck is a bird. So I think that also probably pulled the confidence down for both of those as well. And for a dog, I mean, we could draw dogs so many different ways. There's so many breeds of dogs. Um, you know, who says that all the data is gonna even look the same? We're all gonna draw dogs differently. But anyway, that's basically everything I wanted to showcase for the project. Thank you all for listening, and I hope you all had a great time in this class as well. Thanks. Bye.